Okay, last week we did cosecant and secant. This week, tangent, cotangent. Buckle up, that's all I gotta say. Pay attention, rewind if you have to. The first video is gonna be about tangent. Second video will be cotangent. And then the third video will be how to graph quickly. So, but I do want to talk to you about why it looks like it does, when and where you get vertical asymptotes, and of course why you get vertical asymptotes. So, you should probably print this, by the way, and write it. It's the only time so far I've actually wanted you to write notes or take notes. I guess you don't need to print it, you could just do this on a regular sheet of paper. So, needless to say, almost everything involving trig goes back to the unit circle. It's that important. Let's look at the unit circle again. Voila. This is the x-axis, y-axis, and I'm going to draw a random generic triangle. So if I went right here, it'd be 45. So I'm not going to do a 45. That is not a 45 degree triangle. Our reference angle is right here. Those weird sounds are my dogs. The distance from here to here, I'll call it a generic x. The distance from here to here, I'll call it the generic y. Like that. And so the coordinates of that point on that circle, oh yeah, I forgot, unit circle. So hypotenuse is 1 or radius is 1, that's the definition of a unit circle. The coordinates of this point right here, just a generic x, generic y. Yeah. And start with sine. We know from geometry that sine is opposite over hypotenuse. That is literally the definition of sine. But looking at this generic triangle we have, opposite is y, hypotenuse is 1, or you could just say y. Cosine, definition of cosine is adjacent over hypotenuse. Or in this situation, for this triangle. Hey, you two, knock it off. Sorry, dogs. X over 1. X is the adjacent side, 1 is the hypotenuse. X divided by 1 is just x. Yeah. And next. We are used to reading left to right. So if you think about it, in the normal situation, sine is y, cosine is x. But let's look at it backwards. If you read it from right to left, you get y is sine, x is cosine, x is cosine. Why is that important? Because now you can replace this x with that expression, this y with that expression, and so every time you're looking at a coordinate point on the unit circle, you're really finding the cosine value of whatever angle that is, and the sine value of whatever angle that is. Sorry, that's bad. But here's the nice thing, it's alphabetical. X, Y, that's alphabetical. Cosine, sine, alphabetical. So it's a neat little trick, but it'd be better if you just understood the logic. Logic is better than memorization. Yeah. Okay, now let's go to tangent. Way back in geometry, you learned that tangent is equal to opposite over adjacent. That's the definition. Y over x looks like slope. You'll learn more about that in calculus. And here goes the critical part. Hopefully none of this is difficult. When you forget these properties, you're going to have to recreate a generic triangle, and then hopefully your 6th grade math skills come in. You know that this way is x, this way is y. Certain things you can't forget, obviously, but this whole logical progression, hopefully you don't you can forget rules and whatnot, but hopefully the logic will stick with you. Anyways, I can replace y with sine because they are equal. Yeah, I can replace x with cosine. So what we have is this really important property that says tangent of theta is equal to sine of theta over cosine of theta, which you've been doing this, so this should not be much of a leap. Yeah. And believe it or not, it's this simple fact that determines what the graph of tangent looks like. Okay, so here we go. Tangent. Dun, dun, dun. Unit circle. I'm only highlighting the critical points, the corners of the circle, if you will. And down here, take a look at that. Are you looking at sine or are you looking at cosine? You're looking at cosine, because cosine starts at 1. Cosine, sine. Cosine starts at 1, sine starts at 0. Cosine starts at 1, sine starts at 0. That's old stuff, old news. So, bottom line is, when you're trying to graph tangent, you're going to need to graph cosine first. Why? You learned this in 4th grade, actually, when you first learned about fractions. Which one of these two is the more critical number? Like, is it the top number or the bottom number that's going to be critical? Of course, it's the thing doing the dividing, and you learned something very important in 4th grade, hopefully, that you cannot divide by 0. So, whenever the value of cosine equals 0, you're going to get a vertical asymptote. Let me say that again. Whenever cosine, let me highlight it too, because only the denominator of the fraction is critical. Whenever the value of cosine is 0, you will get a vertical asymptote. Like that. So here we go. When does cosine equal 0? Nope. Yes, so at 90 degrees, right there, at 90 degrees, you're going to get a vertical asymptote. And, nope. Yes, and at 270 degrees, that's not even on here, so let's go backwards. If you notice in the table, I'm going backwards, so. This would be negative 90 degrees. So at negative 90 degrees, and at positive 90 degrees, you get vertical asymptotes. Why? Because the value of cosine is 0 at those two places. Not positive 90 degrees, negative 90 degrees. Dun, dun, dun. Okay. Let's fill out this table. Dun, dun, dun. Tangent is y over x, sine over cosine. So at positive 90, it's 1 divided by 0. Can't divide by 0, you get undefined. So anytime you get undefined, you get a vertical asymptote. Okay? And then over here, at negative 90, same thing. Y divided by x, negative 1 divided by 0 is undefined. Voila! And next, let's do negative 45, which is right here. The coordinates of that point are, let's see, positive, negative. So you get a positive radical 2 over 2 and a negative radical 2 over 2. So, and if you take this divided by this, you get negative 1. and at the, or not origin, but at this point right here at 0 degrees, y divided by x, 0 divided by 1 is 0. And at 45 degrees, right here, coordinates of that point are radical 2 over 2 and radical 2 over 2. Both positive. When you divide something by itself, you get 1. Yeah. So, recap. We get vertical asymptotes whenever we got undefined. Because we're trying to divide by 0, you can't divide by 0. So at negative 90 degrees, right here, you get a vertical asymptote. At 90 degrees, you get a vertical asymptote. And now I'm just going to graph these 3 points. So negative 45, negative 1 is right there. 0, 0 is the origin. And 45, 1. 45, 1. Yeah. And way back in previous lessons, I told you guys a cycle is 4 pieces. Yeah. Well, here's piece number 1. That's part 1. That's part 2. That's part 3. And that is part 4. That is what the graph of tangent looks like. Why does it look like that? Because it's just math. Voila. Now remember, it's a vertical asymptote, so the function can never really touch these lines. That is one cycle of tangent. Took me 12 minutes. Hopefully not too difficult to understand. Summary. Where and when do you get vertical asymptotes? Vertical asymptotes, I'm feeling very lazy obviously, occur when the denominator is 0. Denominator is 0 because you can't divide by 0. Can't divide by 0. Exclamation point. Why is it so sloppy? Because it's 10:38 in the morning, that's why. Okay. Next, we're going to look at cotangent. It's going to be a lot quicker. A lot quicker.